A very good morning to everyone. So my topic is a new formulated model for ductile damage analysis and its comparison to GTN model. Before I start, I would like to thank my supervisor, Dr. Abhishek Tiwari. So we are very well familiar with the GTN model and Rice and Tracy model. I'll not go into it. There's another model, which is JMAK model, also known as Avrami's model, which is not used in damage mechanics, but is a model for phase transformation, solid to solid phase transformation from, let's say, alpha phase to beta phase. So I'll be using Rice and Tracy model and GTN model, the growth rate from Rice and Tracy model and nucleation from GTN model, and I'll incorporate it into Avrami's model. That's how I have formulated a new model. So the mechanism involved in ductile damage is nucleation of void, that void grows, and the collisions of void to form micro cracks and to ultimate damage. Now, the motivation behind developing this model is there are some anomalies in GTN model. So I have tried to figure out some of them and to solve them. So we can see that all the parameters which is used in GTN models, for example, Q1, Q2, Q3, Fn is the void volume fraction that is formed in manufacturing of product. And there are more parameters to it. So these parameters cannot be found experimentally and they are statistically fitted in the model. Same goes for curve fitting of standard deviation and mean of En dot that is defined in nucleation rate of GTN model. So these parameters are statistically fitted. Also in GTN model, the approach is we are adding growth rate with nucleation rate. But if we look into it, these two are not mutually exclusive events. So they are interdependent on each other. So if we are directly adding them, then it's not a suitable approach. Also, as the damage is progressing, the overall volume of matrix is increasing with growth of voids. So in GTN model, it is nowhere considered that with the progress of damage, the volume of void will increase. Another problem is that whenever a void is growing, in that growing area, the nucleation of new void cannot be counted again. So we have to exclude that part in that growing area. So these are the problems. And mesh size influence, if we look into mesh size influence, then we can see, this is from one of the literature, we can see that axial strain and mean void radius are not very much dependent on mesh size. But if we will look into damage and density of void, then we will see that it is somehow dependent on mesh size also. Okay, I'll talk a little bit about JMAK, also known as Avrami's model, and how is my approach going to work for formulation of this model. So how Avrami, let's say if V volume matrix is there, and in that alpha phase is formed, alpha phase is there, and it is going to convert to another phase, let's say beta. So Avrami defines it as nucleation of beta particles at some places, and those beta particles will grow, and it will grow until they impinge upon each other. So nucleation of beta particle, growth of beta particle, and while growth is happening, also there are places where new particles are nucleating of beta phase only. So they will go and impinge upon each other, and whenever the impingement is done, at that time the growth will stop. That's how Avrami approaches the problem. So we will take this idea, I have taken this idea and implemented into our model for void growth and collisions. So Avrami defines that for let's say time period 0 to tau, the nucleation of voids, nucleation of beta particles happens, and from time period tau to t, the voids are growing as well as new voids are nucleating in that ungrown area. So whenever initial volume of matrix was V and growth of beta particles is there to increase the volume of matrix, so he defines the extended volume with this expression, where n dot is the number of nuclei per unit volume per unit time that is growing, that is occurring, and G is the velocity of those voids that are growing. Also, if you look into it, there is some volume on which already a growth is happened. So only a fraction of this extended volume is real. The expression for extended volume, this expression, only a fraction of this extended volume is real, and some part of growth is occurring in already grown area. So Avrami corrects his defined extended volume expression. Now, what he does, he takes the fraction of this volume to original beta phase to exclude those areas where beta has already grown. Now, what I did, my approach for the solution was, let's say I have approached it iteratively. Let's say in ith iteration, the volume that is the growth nucleation of void that is occurring and growing the volume is delta V beta I. Okay. So the void volume fraction, if you will look into terms of void volume fraction, then the void volume fraction will be those volume that has grown in ith iteration to the ratio of the original volume of matrix in I minus 1 iteration. That will define as void volume fraction. So the approach was to take the Rice and Tracy model, growth velocity from Rice and Tracy model, and implement it into Avrami's model. But we also need to define nucleation, number of nuclei that is occurring per unit time. So I used the nucleation rate from GTN model and incorporated to find void volume fraction expression. Now, once I got the void volume fraction, I implemented the model into Abacus explicit using VUMAT subroutine, and some results were as follows. So DT model is Dixit Tiwari model, we have named it. So my model is DT model. So it's in good agreement with the load displacement curve. And when we look into void volume fraction, so DT model is coming, void volume fraction for DT model is coming out to be a little lower than what is in GTR model. Right now, we are working on the experiment results for same. So once I get the result, I'll include that part also. So these are some of the references. Thank you all for your